All right, so it says a study of protein in the oceote of the frog something. We measured the time and the amount of leucine in the two oocytes. I'm not sure what that is, but it asks us to plot the data. So at 0, we have 0.02, which is somewhere close to down there. At 10, we're at 0.25, so about halfway up. At 20, we're at 0.54, so right around there. At 30, we're at 0.69, so maybe somewhere around there. And at 40, we're at 1.07, so up there perhaps. 50, we're at 1.5. And at 60, we're at 1.74, so these are just rough plots here. If I had graph paper, I could make a better show here. And then here I've got the mean of x and the mean of y. Standard deviation of x is 21.6. Standard deviation of y is 0.637. And our correlation coefficient is 0.993. So very high correlation there. Okay? And it also gives us our sum of squares residuals, which is equal to 0.035225. All right, plot the data. Does there appear to be a relationship between x and y? Yes, very strong linear relationship, definitely. Okay. And then it says, use linear regression to estimate the rate of incorporation of the labeled leucine. All right, so in this case, we're going to find our slope, which is r times s sub y over s sub x. So in this case, I've got 0.993 times standard deviation of y is 0.637, and standard deviation of x is 21.6. And so my slope, 993 times 0.637 divided by 21.6, I get 0.029, I'm just round off to 0.293, okay? So that means for every additional second in time, we expect this much more leucine to increase, okay? So that seems to be the rate. This is time. The amount of leucine over time. So for every additional unit of x time, we expect leucine to increase this much. This is our rate of incorporation. Okay. And so my regression intercept is going to be y bar minus b1 times x bar, which is going to be 0.83 minus 0.0293 times my x bar, which is 30. And so I have 0.83 minus that. I have negative 0.049 as my x bar. So my regression line y hat is equal to negative 0.049 plus 0.0293 x, whatever time that is. Okay, and it asks us to plot this regression line. And so it would start down in the negative, and every time I increase, I would go up a tiny bit, and so it looks something like that. And that was just very rough, and I didn't even measure it, but I should be going up and over, or over and up every 10 units and going up 10 times that. So 0.293 increase. All right. And it says calculate the residual standard deviation. So the residual standard deviation is just going to be the square root of SS residuals over n minus 2. And in this case, that's going to be the square root 0.035225 over 1, 2, 3, 4, 5, 6, 7 minus 2 is 5. So that's going to be this tiny little number. Take the square root of that. 0.0839.